Well, we've been using all of these classes that were defined by the actual Smalltalk environment, and now we finally wrote a class ourselves, being the RPNCalculator class. Now, it's worth mentioning at this point that the whole syntax of this file is why we're using GNU Smalltalk instead of one of the more popular, more traditional for Smalltalk distributions such as Pharo. GNU Smalltalk has a simple file syntax for writing a class rather than interacting with a graphical environment, which frankly makes it easier for us to grade, because you can just send us a file. But this doesn't mean that it's not valid as Smalltalk. Indeed, the body of every class, this is exactly how you write Smalltalk code in any language. It's only the syntax for the class itself that doesn't translate. Now, what we're saying is, object, create a subclass called RPNCalculator. So every class has to be a subclass of something. Object is the default global class, like if you've used Java, Java's object is the superclass of every class that doesn't bother to ask for a specific class. So we are going to use object here. Essentially, we're saying we don't care to inherit any behavior, just give me whatever you got. We're declaring an instance variable stack, known as a field in most other languages. We don't call it a field in this case because you can't access it in the way that you could access, say, a C or C++ field. This only exists within these methods in this class. So it does behave a bit more like a local variable than it behaves like a field. However, it does belong to the RPNCalculator, so it's somewhere in between. This odd syntax is how we say we want RPNCalculator new to do something. Normally when we define a method, we're defining it on instances of RPNCalculator, but we want the RPNCalculator class itself to have a new message so that we can create new RPNCalculators. That's going to declare its own local variable R, use objects new to actually create the object itself, and then call init. The reason we have to do this, as mentioned in the module, is that this method can't actually access stack, because this isn't a method on RPNCalculator, it's a method on the class, and Smalltalk has only very private fields. Only the object itself can access its fields. Thus, init does the initialization, and it just needs to put an ordered collection into the stack field so that it's in a good default state. Push just adds to the stack. We've said that you can use a list as a stack by simply adding and removing as appropriate. In this case, we remove from the end. Binary is doing a binary operation. We're going to essentially use a lambda so you can pass in what binary operation you want to do. Note the order that we popped these, y then x, so right then left. The reason being that in most reverse Polish notation calculators, if you do 1, 2, minus, you expect 1 minus 2, not 2 minus 1, so you have to do these in the opposite order. So we get y, then x, and then the way to call this block, as if it was a lambda function, is of course calling a method, in this case the value method, and we pass x as the first value and y as the second value. Then, because this is an RPNCalculator, we add the result back to the stack, and we return the result. By making a binary method, we've made the add, sub, mul, and div methods much, much simpler, because they can just call binary and pass in a block that does the one little bit of math that you want them to do. And that also means if I had some other binary operator, like the @ I introduced in a previous video, we could call binary directly. Let's go ahead and use the RPNCalculator. If I just run gst rpn.st, nothing seems to happen. Well, that's because rpn.st doesn't do anything, it just loads a class. It has no behavior, we haven't run the class, we haven't done anything with the class, we just loaded it. But if I go to the shell, now I am picky about declaring variables. Technically, GNU Smalltalk is pretty lax about declaring your variables. I like to always declare them just so that it's clear. Anyway, I can create an RPN calculator, and if I push 1, and say push 2, and add, I'll get that 1 plus 2 is 3, and then the way an RPN calculator works is that's now on the stack. So if I say push 5, and then xdiv, I'll get 3 divided by 5, which is, well, 3 divided by 5. Smalltalk has several ways of storing numbers. It can store plain integers, of course. It can also store exact fractions, as well as the floating point numbers you've probably seen in many other languages. If you want to be picky about it, well, that's what we're going to talk about in the next section. In this case, it shows an exact fraction for 3 divided by 5.